Technically speaking, we have been scanning the stars and wondering what is out there in the universe for hundreds of years. But it's been within the last 100 or so years that we've honestly made the biggest progress. Through telescopes and satellites, we have gone and made observations and discoveries that have almost literally blown our minds. And we're always looking to advance those technologies to get even better discoveries made. Which is exactly what is intended to happen with the latest major telescope to go up into the sky. Allow us to show you the mind-blowing capabilities of the James Webb Space Telescope. The launch. Exploring strange new worlds. Understanding the origins of the universe. Searching for life in the galaxy. These are not the plot of a new science fiction movie, but the mission objectives of the James Webb Space Telescope, the long-awaited successor to the Hubble Space Telescope. On Christmas, NASA launched the Webb from French Guiana in partnership with the European Space Agency and the Canadian Space Agency. Now the telescope is on its way to a point nearly 1 million miles away from Earth. On its journey, the telescope has to complete a difficult mechanical maneuver, assembling itself. The telescope is so large it needed to launch folded up inside a rocket. Over the course of several weeks, it needs to unfurl its various components from its sunshield to its mirrors. According to NASA, more than 300 potential technical problems or single-point failures could potentially doom the mission. But when it fully deploys in space, the Webb will usher in a new age of astronomy, scientists say, and show humanity things it has never seen before. A bold claim given all that we've witnessed from space from various other vessels and craft. But apparently, this one will live up to the hype. Decades in the making. The Webb represents the culmination of decades, if not centuries, of astronomy, says Sarah Seeger, a planetary scientist and astrophysicist at MIT. We've been waiting for this for a very long time. Scientists started thinking about a follow-up even before the Hubble Space Telescope launched in 1990. After more than 3 decades in space, it's unclear how much longer this boundary-breaking satellite will be able to scan and photograph the universe. The Webb was originally supposed to launch in 2010 and cost around $1 billion. Its price tag ballooned to $10 billion, and it's way overdue. But the wait will be worth it, at least according to the scientists who expect new and revealing glimpses of our universe. We're going right up to the edge of the observable universe with Webb, says Caitlin Casey, an assistant professor of astronomy at the University of Texas at Austin. And yeah, we're excited to see what's there. The Webb will surpass the Hubble in several ways. It will allow astronomers to look not only farther out in space, but also farther back in time. It will search for the first stars and galaxies of the universe. It will allow scientists to make careful studies of numerous exoplanets, planets that orbit stars other than our sun, and even embark on a search for signs of life there. The Webb is a machine for answering unanswered questions about the universe, for exploring what has been unexplorable until now. From Hubble to Webb. The launch of the Hubble Space Telescope, named after famed astronomer Edwin Hubble, was itself a huge leap forward for astronomy. Here on Earth, astronomers seek out remote mountaintops and deserts to build major telescopes for the best chance of viewing a dark sky away from pollution and bright lights. But their view is still marred by the slight haze and luminescence of the Earth's atmosphere. Space is the ultimate mountaintop, as NASA explains. There's no better view of space than the one from, well, space. Hubble has meant so much during its 30-year run. For one thing, it sent us unforgettable, jaw-droppingly beautiful images like those of the Lagoon Nebula and the Pillars of Creation. It's also taught us about the age of the universe, about what happens when stars explode, and about black holes. It helped establish many of the boundaries that the Webb hopes to push. Most powerfully, its observations have led scientists to believe the universe is expanding at an accelerating rate, propelled by something so mysterious that scientists simply call it dark energy. The Webb is, controversially, named for the man who led NASA in the decade leading up to the moon landing. James Webb, its namesake, was a government bureaucrat at a time when it was federal policy to fire gay staffers. While current NASA Administrator Bill Nelson has said that the agency has found no evidence at this time that warrants changing the name of the James Webb Space Telescope, more than 1,700 people have signed a petition accusing Webb of complicity in a discriminatory policy. Namesake aside, the technological achievement of NASA's newest telescope is uncontroversial. It's set to take the success of the Hubble a step further. What we're going to get is a telescope that's about 100 times more powerful than Hubble, says Amber Strawn, an astrophysicist at NASA who works on the Webb. how the Webb telescope is better than the Hubble. The Webb improves on Hubble in two key ways. The first is just its size. Hubble was about the size of a school bus, whereas Webb is more like the size of a tennis court. This thing is enormous, Strawn says. Webb is by far the biggest telescope NASA's ever attempted to send into space. But it's not just the total size of the contraption that matters. When it comes to reflecting telescopes, the key component is the size of its curved mirror. You could sort of think of a telescope mirror like a light bucket, Strawn says. The more light you can collect in this bucket, the fainter and farther away things you can see in the universe. Hubble's mirror was an impressive 7.8 feet in diameter. Webb's beautiful gold-hued mirrors combined for a diameter of 21.3 feet. Overall, that amounts to more than 6 times the light collecting area. What does that mean in practice? Well, consider one of Hubble's most famous images, the Deep Field. In 1995, scientists set the Hubble to stare off into a teeny tiny patch of sky, about the size of a head of a pinhead, held at arm's length from the viewer, and capture as much light as it could from that one spot. The image that came back was astounding. Hubble uncovered thousands of galaxies in this teensy patch of sky, helping us refine the number of galaxies thought to exist in the universe. In astronomy, the further away things are, the older they are, because light from faraway places takes a very long time to travel to Earth. That means this Hubble Deep Field is not only a snapshot of space, it also contains the history of our universe. Galaxies in this image appear to us as they were billions of years ago. What Webb will do is take that field and go even further. UT Austin's Casey explains. So, the tiny specks of light in the background of the Hubble Deep Field will brighten and become more detailed. We'll be able to see spiral arms. We'll be able to see structure. And then, we'll get more specks of light even further in the past. We're seeing further back in time with Webb. Spotting what came before. With Webb, astronomers like Casey will be able to see so far back that they'll potentially spot the very first stars and galaxies. Hubble has seen light dating to about 400 million years after the Big Bang, which took about 13.3 billion years to reach us. That's far. But Webb has the capability to take us 250 million years after the Big Bang, explains Casey, who has been approved to work with the Webb Space Telescope. It might not sound like a big difference. What's a few 100 million years between friends? Actually, it's the difference between seeing the first stars that ever turned on and arriving a bit too late after the funeral. Astronomers call this period when the first starlight shone through the universe cosmic dawn. With the Webb, humanity will be able to get a glimpse at it for the very first time. Seeing the light. The Webb's other advantage is the type of light it collects. Light comes in a lot of different varieties. The human eye can only see a narrow band known as visible light, but the universe contains lots and lots of light outside this range, including the higher frequency, higher energy forms, ultraviolet gamma rays. Then there's the lower energy light with longer wavelengths, infrared, microwaves, and radio. The Hubble Space Telescope collects visible light, ultraviolet, and a little bit of infrared. The Webb is primarily an infrared telescope, so it sees light that's in a longer wavelength than what our eyes can see. This seems nerdy and technical, but it's actually what allows Webb to look further back in time than the Hubble. So, as you can see, there are a lot of things that NASA and others are looking forward to with this telescope. What it'll show and whether it can make itself work without issue is something we'll just have to wait on. So, what do you think? What do you think of this look at the James Webb Space Telescope and what it might be able to reveal about the universe? Do you feel that the discoveries this telescope will make will honestly be groundbreaking? What do you personally think it'll find that will help advance research into our universe? Let us know in the comments below, and we'll see you next time on the channel.